Ever wondered how massive construction projects get started? It's a complex dance of planning, precision, and a deep understanding of the land. Before the first brick is laid or the first beam is raised, a crucial step takes place: surveying. This initial assessment sets the stage for everything that follows, ensuring accuracy and preventing costly errors down the line. Traditionally, surveyors painstakingly mapped every inch of land, using tools like theodolites and levels to measure angles and distances. It was a process that took time and patience, requiring meticulous attention to detail and a deep understanding of terrain. Each measurement was carefully recorded, and every calculation was double-checked. But now drones are buzzing onto the scene, offering a new perspective and a faster way to gather data. They're challenging the old ways, promising increased efficiency and accuracy. Can these flying machines really take over the foundational work of surveying? Can they replace the boots-on-the-ground approach that has been the standard for so long? Drones offer faster data acquisition, covering large areas in a fraction of the time it would take a traditional surveyor. They're also safer, allowing surveyors to avoid hazardous or difficult-to-reach areas. And they provide more detailed data collection than ever before, capturing high-resolution images and 3D models with incredible precision. They're not just toys, they are sophisticated tools equipped with advanced sensors and software. They're becoming essential tools for civil engineers, architects, and construction managers. This shift is revolutionizing how we plan, design, and execute construction projects. It's changing how we build, allowing for more efficient and sustainable construction practices. And it's transforming how we maintain infrastructure, enabling proactive monitoring and timely repairs. For future engineers, it's an exciting time, a time of innovation and technological advancement. The tools are evolving rapidly, pushing the boundaries of what's possible in the field of surveying. Drones represent a leap forward, offering unprecedented capabilities and insights. It's not just in technology, but in mindset, requiring a willingness to embrace new approaches and adapt to changing times. They gather millions of data points in a single flight, providing a comprehensive view of the terrain. This data is then used to create digital twins of the real world, allowing engineers to visualize and analyze the site in detail. This isn't just an upgrade, it's a paradigm shift in how we approach surveying. It's a transformation in how we gather information, analyze data, and make informed decisions. The era of drone-assisted surveying is here, and it's changing the landscape of construction, and every engineer needs to understand its impact, embracing the technology, and adapting to the future of surveying. Using drones for engineering applications used to be a significant legal headache. The regulatory landscape was murky, and navigating the rules felt like trying to solve a complex puzzle with missing pieces. Many engineers found themselves spending more time deciphering legal jargon than actually utilizing the technology. The unclear and often contradictory rules kept many companies on the sidelines, hesitant to invest in drone technology due to the perceived legal risks and uncertainties. This hesitation stifled innovation and prevented the widespread adoption of drones in the engineering sector. But now, forward-thinking governments around the world have recognized the immense benefits that drones can bring to engineering and construction, and have taken steps to set clear and comprehensive guidelines for their use. This proactive approach is paving the way for a new era of efficiency and innovation. In the United States, the Federal Aviation Administration's Part 107 regulations have made it significantly simpler and more accessible for individuals to become certified commercial drone pilots, ensuring a baseline level of competence and safety in drone operations. This streamlined certification process has been a game changer for the industry. This regulatory clarity has opened the door for engineering firms of all sizes to confidently, safely, and legally integrate drones into their projects, unlocking a wide range of new capabilities and efficiencies. From site surveying to progress monitoring, the possibilities are endless. In Europe, the ambitious U-Space framework is actively creating a sophisticated highway in the sky specifically designed for drones, particularly in densely populated urban environments where efficient and safe drone traffic management is paramount. This innovative approach promises to revolutionize urban logistics and infrastructure management. These comprehensive regulations are designed to ensure that drones can operate safely and responsibly while seamlessly coexisting alongside traditional manned aircraft, minimizing the risk of collisions and ensuring the safety of all airspace users. The ultimate result of these efforts? A resounding green light for unprecedented innovation and progress in the field of civil engineering. Engineering professionals can now confidently and efficiently use drones for a wide range of critical tasks, including detailed data collection, comprehensive site monitoring, and thorough infrastructure inspections. all while adhering to clearly defined legal standards. This newfound legal clarity has unlocked a wealth of new possibilities and opportunities, rapidly transforming drone-assisted engineering from a niche application into the new industry standard for efficiency and accuracy. With these well-defined rules and regulations firmly in place, the engineering and construction industry is moving forward at a pace faster and more efficiently than ever before imagined. Drones are no longer relegated to a legal gray area of uncertainty and ambiguity. Instead, they have emerged as a fully regulated and exceptionally reliable tool for engineering professionals. The future of engineering is being built upon this solid foundation of enhanced safety, regulatory compliance, and groundbreaking innovation. In civil engineering, time is money. Every day counts, and delays can be incredibly costly. Efficient project management is paramount to success. And traditional land surveys, while reliable, are often slow and labor-intensive. They can become a significant bottleneck in the construction process. Surveyors meticulously walk the site, covering every inch of the terrain to gather necessary data. This process can be physically demanding and time-consuming. They carefully set up equipment, ensuring precise alignment and calibration for accurate measurements. This setup process alone can take a considerable amount of time. And then, they take measurements one by one, painstakingly recording each data point. This manual process is prone to human error and can be incredibly tedious. This entire process can stretch for days or even weeks, depending on the size and complexity of the site. This extended timeline can significantly impact the overall project schedule. Enter drones, a game-changing technology that's revolutionizing the surveying industry. Now, a single operator can map a huge area in hours, not days, dramatically accelerating the initial stages of a project. This speed translates directly into cost savings and faster project completion. Drones capture high-resolution images from multiple angles, providing a comprehensive visual record of the site. These images are then processed to create detailed maps and 3D models, accelerating the entire project timeline and providing invaluable insights for planning and execution. Faster data means earlier design, allowing engineers to begin planning and designing with up-to-date information. This leads to quicker problem-solving, fewer delays, and ultimately, a more efficient and cost-effective construction process. Drone surveys aren't just faster. They offer a range of other benefits that traditional methods simply can't match. They're more comprehensive, providing a complete and detailed overview of the entire site. While ground surveyors sample points, focusing on specific locations and features, drones collect continuous data across the whole site, capturing every detail and providing a holistic view. The result? Richer, more complete information for engineers, allowing them to make more informed decisions and optimize their designs. This combination of speed and detail is transforming the industry, ushering in a new era of efficiency and accuracy. Drones don't cut corners. They provide highly accurate and reliable data. They raise the bar for accuracy and efficiency, setting a new standard for surveying in the 21st century. Projects start sooner, finish faster, and run more smoothly, thanks to the power of drone technology. The old bottlenecks are gone. The delays and inefficiencies of traditional surveying are becoming a thing of the past. Drones are the new standard, the go-to solution for surveying professionals seeking speed, accuracy, and comprehensive data. In today's world, drones are the surveyor's most powerful tool, transforming the way we approach construction and engineering projects. Inspecting bridges in cities like San Francisco used to mean lane closures, traffic jams, and risky work. But one engineering team tried something new. They used a drone. The drone flew under and around the bridge, capturing detailed images from every angle. No need for heavy equipment or dangerous climbs, just fast, safe data collection. The result? The inspection was completed 30% faster, with no disruption to traffic. Engineers reviewed high-definition footage from their office, zooming in on problem areas. It was safer, cheaper, and far less disruptive. This success story isn't unique. Drones are now standard for bridge inspections worldwide. They're not just gadgets. They're essential tools for modern civil engineers. Drones have redefined what's possible in infrastructure inspection. The future of safe, efficient bridge inspections is already here. How do drones turn photos into 3D models? The answer? Photogrammetry. Drones fly in a grid, snapping hundreds of overlapping images from different angles. Smart software stitches these photos together, identifying common points to build a dense 3D point cloud. This digital skeleton becomes the foundation for detailed maps and models. Engineers get highly accurate 3D terrain models and orthomosaic maps, perfect for planning and measurement. Need to calculate how much soil to move? The drone's data makes it easy. Before construction begins, teams can explore the site virtually, spot challenges, and test designs. This insight prevents costly mistakes and streamlines the entire project. Drone photogrammetry is transforming how engineers plan and build. The digital twin is now a reality, thanks to drones. Building a modern stadium is a massive challenge. Every piece must fit perfectly. Even small errors can cause big delays and costs. In London, a stadium project used drones to survey the site at every stage. Drones captured real-time data, compared it to digital design models, and flagged discrepancies early. A steel beam a few centimeters off? The drone caught it before it became a bigger problem. This proactive approach saved time and money by preventing costly rework. Drones provide real-time quality assurance, ensuring construction matches the plan. It's not just about starting right, it's about staying right throughout the build. Drones help keep projects on schedule and on budget. The combination of digital models and drone data is a game changer for quality control. Inspecting massive structures, skyscrapers, bridges, wind turbines, can be dangerous and slow. Drones are changing that, making inspections safer and more efficient. Inspectors stay on the ground while drones get close to hard-to-reach areas, capturing high-res images and thermal data. Regular drone inspections mean problems are caught early, before they become serious. At a Texas wind farm, drones spotted tiny cracks in turbine blades, allowing for quick, inexpensive repairs. This prevented costly failures and reduced downtime. Drones enable smarter, predictive maintenance for critical infrastructure. They save money, time, and lives. The future of structural safety is airborne. Today's drones are smart, but the future is even brighter. Artificial intelligence is making drones capable of analyzing images in real time, flagging defects automatically. This means faster, more accurate inspections. Engineers focus on solutions, not sifting through data. Drones are also integrating with building information modeling, BIM, and geographic information systems, GIS. Overlaying drone data onto digital models creates a unified, real-time view of a project. Project managers can track progress, spot issues, and communicate with stakeholders more effectively. In Dubai, time-lapse drone footage linked to BIM and GIS kept a highway project on track. This connected ecosystem is the future of digital construction. Drones are the key data link in this smart, integrated workflow. Can drones replace traditional surveyors? Not entirely, but they're transforming the field. Drones enhance old methods, delivering faster, safer, and more detailed data. From surveys to inspections, drones touch every phase of a project. Regulations have paved the way for widespread adoption. Photogrammetry, real-time monitoring, and predictive maintenance are now standard. Integration with AI, BIM, and GIS is making drones even more powerful. For future engineers, mastering drone technology is essential. Drones are laying the foundation for the next era of civil engineering.